In the last video, we talked about two basic vector operations, scalar multiplication and vector addition. Now let's see what happens when we combine them. Suppose we have two vectors, v and w. We can multiply each of them by any number, and then add the resulting vectors together. Remember, we can use the tip-to-tail method to find their sum, so I'll place the second vector at the end of the first vector each time. As we saw before, this creates another vector. Now let's try different values for those two numbers. This is called a linear combination. Each choice gives us a different resultant vector. And if we allow every possible scalar, we get every vector that can be created from v and w. This entire set is called the span of v and w. This is how we mathematically describe the span of v and w. Now let me explain what these symbols mean. The first part tells us what this set contains. Vectors created in the form AV plus BW. Combination of the scaled versions of v and w. This vertical line means such that. And the second part tells us that a and b can be any real numbers. So this notation simply means the set of every possible linear combination of v and w. Just like we can visualize vector addition, we can also visualize the span. In this case, there are two possibilities. If v and w lie along the same line, then no matter how we change their coefficients, every resultant vector will lie along that same line. If we use each vector's endpoint to represent it, this set of endpoints forms a straight line. But if v and w don't lie along the same line, changing their coefficients allows us to create every possible vector in 2D. Yes, every single one. I'll show you why this works in the next video. If we represent each of these vectors by its endpoint, the endpoints fill the entire 2D plane.